Hello, Mr. Collier here. This is the final video in our Lab 5B friction series, and in this video I'm going to show you how to do the calculations that go with the data that I showed you in part 2. So the first piece of this lab was the angled track, and you sent down both the regular car and then the car with the sail on it for additional friction. Table 1 is your control speeds, and in this table you should have gotten the AB time, and I'm going to use the example from the data that I collected, which the AB time for the first trial was 0.3538 seconds. The distance between the two photo gates was 50.00 centimeters, and now we're going to calculate the average speed. So average speed is distance divided by time. Our total distance is 50 centimeters, and we're going to divide that by our time, 0.3538, and that's going to come out to 141.3. So that's my first example, and that's for the control speed. I'm going to give you a second example, and that will be for the second table, the sail car. So this was the car that had the paper plate attached to it. Again, I'm using the data from part 2 of this video series. The first data point for the sail car was 0.4053 seconds. Again, the photo gates are 50 centimeters apart, and velocity equals distance divided by time, 50 centimeters divided by 0.4053 seconds. Punch that into a calculator and you should get 123.4. Before I move to the next part, let me just mention this 50 centimeters. We're using that as our distance between A and B. Because you can't calculate the instantaneous speed because of that popsicle stick on the sail car. It prevents you from using the 1 centimeter flag for any of your distances, so we just have to take the average speed between the two photo gates. In the second half of Lab 5B, you set up a flat track and sent two different cars down, a sled car to measure sliding friction and a regular car to measure rolling friction. I'm going to show you how to do the sliding friction data calculations, but then everything I show you here is exactly the same on table 4 for the rolling friction. I'm going to use again the data that came from the second part of this video series. So the A time was 0.0055 seconds, the B time was 0.0084 seconds, and the AB time was 0.3354 seconds. To calculate the speed through A, you're going to do velocity equals distance divided by time, and in this case the distance is 1.00 centimeters, and you're going to use the time A. So that's going to be, and I'm going to go to the bottom here, 1.00 divided by 0.0055. That's going to give us a speed A of 182 centimeters per second. If I do the same thing with B, it's going to be 1.00, but now I divide it by the B time, 0.0084, and that's going to give me a B speed of 119 centimeters per second. Finally, I'm going to calculate the acceleration. Acceleration is change in speed over change in time. So I'm going to use speed B minus speed A divided by the time A to B. Let's go over here for that. So speed B is 119 minus speed A, which is 182. If you're doing that in a calculator, you'll want parentheses, and I'm dividing it by the AB time, 0.3354. That's going to give me my acceleration, and it will be negative 188 centimeters per second squared. The negative tells me that the car is slowing down, which makes sense. It's on a flat track, and all we have is friction. You're going to use all of these same methods to calculate the speeds and accelerations for Table 4. And what you'll find is that the friction there is a little bit less, and so the car does not slow down nearly as much. And that is it for Lab 5B, friction. We've now seen 3 different kinds of friction: sliding, rolling, and air friction, sometimes called drag or air resistance.